whether you can
Yes,
speak.
I can hear you. Thank you very much.
Wonderful, thank you. Hi, Professor Edward Arrow. Could you help me? Hello? Hello, Professor Arrow. Could you help me? I cannot hear your voice. I just want to test whether we can hear your voice. No? No, sorry, I cannot hear you. I can hear myself. No, I just hear the Topion professor, but I couldn't hear Edward. Yeah. Channel 2. Hi, Professor Edward Arrow. I couldn't hear you. Could you repeat?
Wear your headset
Yes,
too. Thank
I think
you.
you can hear, right? Okay, I know. Yeah, thank you.
Take your headset.
Okay, thank you.
Hello everyone. Please wear your headset and turn to channel 2.
Hello. Yes, I can hear you. Okay, wonderful. Okay, thank you so much. Yes. Yes. Could you help me? Channel 2, right? Can you help me? Okay. Okay. Ladies and gentlemen, good morning. Welcome to this open forum, Digital Technology Empowering Green and Low Carbon Development. My name is Fang Zhang. I'm an associate professor from the Institute of Intelligent Society Governance, Tsinghua University. It's my honor to serve as a moderate for this forum today. First, on behalf of the organizers, I would like to extend a warm welcome to our distinguished experts and audience here or online. This forum focuses on the critical intersection between the digital technology and green low carbon development. We are very honored to have 9 speakers with us today. 7 of them will join on the site, and 2 will join remotely. As you can see from the agenda, we have a very packed and but exciting program ahead. To kick off the forum, please let me to invite Mr. Nong Kai, Deputy General Director of the Bureau of Information Technology Development Cyberspace Administration of China, to deliver the opening remarks. Welcome.
尊敬的各位来宾、女士们、先生们，大家上午好。
Distinguished guests, ladies and gentlemen, good morning.
欢迎参加第19届 IGF 数字技术赋能绿色低碳发展开放论坛。
Welcome to the 19th IGF Open Forum on Digital Technology Empowers Green and Low Carbon Development.
很高兴和大家相聚在利雅得。我谨代表论坛的主办方中国国家互联网信息办公室、信息化发展局，感谢各位的参与，也特别感谢今年主办国沙特阿拉伯王国为本届论坛所做出的辛勤努力和付出。
It's a great pleasure to meet all of you here in Riyadh. On behalf of the organizer, the Bureau of Digitalization Development, Cyberspace Administration of China, I would like to express our gratitude for your participation. I would also like to extend special thanks to the Kingdom of Saudi Arabia, this year's host country of IGF, for their extraordinary work and dedication to the success of this forum.
中国政府高度重视数字化、绿色化协同发展，致力于推动数字技术赋能绿色低碳发展。习近平主席强调，要加强经济技术合作，加速数字化、绿色化协同发展，推进能源、资源、产业结构、消费结构转型升级，推动经济社会绿色发展。
The Chinese government places great importance on the coordination between digitalization and green transformation, and is committed to promoting the empowerment of green and low-carbon development through the adoption of digital technologies. President Xi Jinping emphasized the need to strengthen economic and technological cooperation, accelerate the coordination of digitalization and green transformation, and advance the upgrading of energy resources, industrial structures, and consumption patterns to foster green socio-economic development.
中国共产党20届三中全会提出，支持企业用数字技术、绿色技术改造提升传统产业。今年7月，中国政府印发《关于加快经济社会发展全面绿色转型的意见》，提出加快数字化、绿色化协同转型发展，也就是双化协同。
The 20th National Congress of the Communist Party of China proposed that we will support enterprises in upgrading traditional industry via AI and green technologies. In July 2024, the Chinese government issued a policy document, Guidelines on Accelerating the Comprehensive Green Transformation of Socio-Ecological Development, which further outlines the acceleration of coordination between digital transformation and green technology.
近年来，中国组织实施了双化协同行动计划，主要任务包括3个方面：一是推动数字产业绿色低碳发展；二是利用数字技术赋能传统行业绿色转型；三是以传统行业绿色转型带动数字产业发展。
In recent years, China has launched the action plans on the coordination between digitalization and green technology, focusing on 3 main tasks. First, promoting green and low-carbon development of digital industry. Second, leveraging digital technologies to empower the green transformation of traditional industries. Third, driving the development of the digital industry through the green transformation of traditional industries.
围绕这3方面任务，部署了一系列的重点任务，选择中国境内10个城市开展了试点示范，取得了积极进展和成效。探索积累了一系列可以复制、可推广的案例经验。
To achieve these goals, a set of initiatives have been implemented, including pilot projects in 10 cities in China. By so far, these efforts has gained significant progress and results, providing replicable and scalable examples.
当前，数字化、绿色化已经日益成为全球经济社会转型发展的重要趋势。实践证明，数字技术能够与能源电力、工业、交通、建筑等重点碳排放领域深度融合，有效提升能源与资源的使用效率，对传统行业绿色转型具有积极作用。从全球范围看，双化协同已经成为推动经济社会可持续发展的关键核心力量。借此机会，我谈几点感受，与大家分享。
We believe that digitalization and green transformation are increasingly becoming notable trends in the global development. Practical evidence has shown that digital technologies can deeply integrate with a set of key sectors such as energy, power, industry, transportation, and constructions in carbon reduction. This integration effectively enhances the efficiency of energy and resource utilization, playing a pivotal role in the green transformation of traditional industry. From a global perspective, this coordination has become key driving forces of sustainable global growth. On this occasion, I would like to share a few insights.
一是创新引领发展，我们要推动双化协同技术创新、研发和应用，加强基础研究和前沿技术布局，强化企业科技创新主体地位，促进技术成果转化应用，不断催生新产业、新模式、新动能。
First, innovation drives development. We need to foster technological innovation and application in the coordination between digitalization and green technology. This includes strengthening fundamental research and the deployment of cutting edge technologies, enhancing the role of enterprises as the primary driver of technological innovation, promoting commercialization of technology, and continuously nurturing new industries and business models.
要聚焦数据中心、通信基站、电子信息产品制造和使用，加快节能降碳技术的研发推广，促进数字产业绿色低碳发展。
Particular focus should be placed on the development and promotion of energy saving and carbon reducing technologies in a set of areas such as data centers, communication base stations, and the manufacturing of electronic products to facilitate the green and low carbon development of the digital industry.
三是融合促进发展，数字技术能够为经济社会绿色发展提供网络化、数字化、智能化的手段，推动社会总体能耗和碳排放降低。
Second, integration leads to development. Digital technologies can provide networked, digitized, and intelligent tools for green transformation, contributing to reduce overall energy consumption and carbon emissions.
我们要加快数字化、绿色化融合创新，推动互联网、大数据、人工智能、第五代移动通信等新兴技术与绿色低碳产业深度融合，加快数字技术、赋能工业、能源、建筑、交通等重点行业绿色转型，推动产业结构由高碳向低碳，由低端向高端发展。
Efforts should be made to accelerate the fusion of digitalization and green transformation, driving the deep integration of emerging technologies such as internet, big data, artificial intelligence, and 5G with green and low carbon industries. This will enable the green transformation of key sectors such as industry, energy, construction, and transportation, shifting industrial structures from high carbon to low carbon and from low end to high end.
三是开放共赢发展，数字化和绿色化是当今世界各国发展面临的共同机遇。我们要持续深化拓展双化协同领域，多双边对话合作，加强双化协同领域技术规则、标准制定，推动政策沟通、科技交流、项目合作、人才培训，让双化协同成为推动构建人类命运共同体的重要内容。
Third, openness makes development mutually beneficial. Digitalization and green transformation are shared opportunities for countries all over the world. We should further deepen and expand bilateral and multilateral dialogue and cooperation in this field. This includes strengthening the formulation of technical rules and standards, promoting policy coordination, technological communication, project collaboration, and talent training. We hope this will become a key element in efforts to advance the shared future of humanity.
女士们、先生们、朋友们，今天的论坛为双化协同搭建了很好的交流平台。来自全球本领域的知名教授、专家、学者、产业界企业代表齐聚一堂，希望大家深化交流，加强合作，共谋发展，共同探讨未来双化协同的最佳实践，共建美丽地球，共享绿色未来。
Ladies and gentlemen, dear friends, today's forum provides an excellent platform for discussion on the coordination between digitalization and green development, gathering professors, experts, scholars, and industry representatives from around the world. Let's further deepen communication, strengthen cooperation, and provide better insights into the best practice in this field, contributing to the shared green future and the beautiful Earth.
最后，预祝论坛取得圆满成功，谢谢大家。
Finally, I wish this forum great success. Thank you all.
Thank you.
Thank you, Director Nong Kai, for your insightful remarks. Now let me invite Professor Peng Gang, Vice President and Provost of Tsinghua University, to deliver opening remarks. Please welcome.
尊敬的龚科教授、王建超局长、龙凯局长、各位嘉宾，来自全球各地的朋友们，大家上午好。
Distinguished guests and esteemed guests from all over the world, good morning.
很高兴与大家相聚在联合国互联网治理论坛，共同探讨数字技术助力绿色低碳发展的时代命题。首先，我要代表清华大学，作为本次开放论坛的承办方，向各位专家的拨冗出席表示最热烈的欢迎和最衷心的感谢。
It's a great pleasure to meet all of you here on the 19th IGF. This forum provides us a great chance to have a discussion on leveraging digital technology for green and low carbon development, a crucial topic for today's world. On behalf of Tsinghua University, the co-organizer of this open forum, I want to extend my warmest welcome and sincere gratitude to all the experts and guests here.
当今世界数字时代的绿色低碳发展已经成为全球治理的焦点议题。中国国家主席习近平强调，推动经济社会发展的绿色化、低碳化是实现高质量发展的关键环节。
Green and low carbon development in this digital era is a focusing topic of global governance in today's world. Chinese President Xi Jinping has emphasized that green and low carbon transformation is the key to high quality development.
2024年7月，中国政府发布了关于加快经济社会发展全面绿色转型的意见，指出要推进产业数字化、智能化同绿色化的深度融合，实现数字技术赋能绿色转型。数字化、绿色化两大战略正迎来历史性的交汇，为未来一段时期中国乃至世界的高质量发展提供了强劲的动力。
In July 2024, the Chinese government issued the guidelines on accelerating the comprehensive green transformation of socio-economic development, advocating for deep integration of digitalization and green development to drive this transition. The convergence of these strategies greatly promote sustainable growth in China and global countries.
作为人类科技进步和社会发展的思想策源地，大学理应在探索数字化、助力绿色低碳发展的进程中扮演重要的角色。近年来，清华大学高度重视开展数字技术助力绿色低碳发展的交叉学科的探索。
Universities, as hubs of innovation and leadership in thought, should play a vital role in advancing this agenda. At Tsinghua University, we have prioritized interdisciplinary research at the intersections of digital technology and green development.
清华大学不仅是中国国内最早开展人工智能教学和科研的单位之一，近年来还先后成立了低碳能源实验室、碳中和研究院等多个教学科研机构，为相关交叉学科的研究奠定了坚实的基础。
As one of China's pioneers in AI research and education, we have also established institutions such as Low Carbon Energy Lab and Institute for Carbon Neutrality, laying a solid foundation for such interdisciplinary exploration.
与此同时，我们也高度重视数字技术应用背后的社会性问题，在2019年成立了智能社会治理研究院，深入研究数字技术助力低碳发展等一系列智能社会的基础性的理论和政策的议题。5年来，研究院已在上述领域取得了一系列重要的成果，为全球智能社会治理有力地贡献了中国经验。
In the meantime, we also recognize the societal challenges posed by digital technology. In 2019, we established the Institute for Intelligent Society Governance, focusing on fundamental theories and policies issues related to digital technologies and low carbon development. Over the past 5 years, the Institute has made significant contributions to global intelligent governance through research and policy insights.
在中国国家互联网信息办公室的大力支持下，清华大学承办了本次数字技术助力绿色低碳发展的开放论坛。我们先后邀请到来自联合国、中国、新加坡、澳大利亚等多个国家和国际组织的资深专家，希望以此为契机，进一步的围绕数字技术与绿色发展的问题，搭建高水平的国际对话交流平台。衷心期待各位专家各抒己见，让我们在思维火花的碰撞中进一步的深化交流，共谋发展，为数字技术助力绿色低碳发展的全球实践贡献新的智慧。
With the guidance from the Cyberspace Administration of China, we are proud to host this forum, bringing together experts from the United Nations, China, Singapore, Australia, and other nations and global organizations. This forum aims to foster high-level dialogue and collaboration, generating fresh ideas and advancing global practice in digitalized green development.
借此机会，我也想与各位嘉宾交流几点建议：一是要发力在人才培养，持续的开展人工智能、绿色低碳技术、智能社会治理等交叉学科的建设，培养兼具数字技术的基础和社会人文关怀的高水平的复合型人才。
Regarding this issue, I would like to share 3 key thoughts with all of you. First, we should pay more attention to the cultivation of young talent. To achieve this goal, we should strengthen interdisciplinary education in AI, green technologies, and societal governance to cultivate outstanding talent with technical expertise and societal awareness.
二是要完善交流机制，深化政产学研多方主体围绕数字技术助力绿色发展的重大理论和实践问题开展协同攻关，推动相关领域的基础研究和创新应用不断地迈上新的台阶。
Second, we should further enhance collaboration among stakeholders. In the coming years, we will deepen partnerships among governments, industries, academia, and research institutions to address fundamental and practical challenges, driving innovation and application.
三是深化国际合作，重点推动全球各国在数字化、绿色化协同发展领域的技术共享、标准对接与资金融通，推动数字技术发展的福祉更加普惠共享。
Third, we should promote global cooperation, which focuses on advancing international collaboration in technology communications, standards alignment, and financial integration. We can further make the welfare brought by technological evolution more inclusive.
最后，预祝本次论坛取得圆满的成功，谢谢大家。
I wish this forum great success. Thank you.
Thank you, President Peng Gang, for your inspiring speech. Now let's turn to our distinguished panel of experts to share their insights on the theme today. Our first speaker is Professor Gong Ke, former president of the World Federation of Engineering Organizations, and also executive director of Chinese Institute for New Generation Artificial Intelligence Development Strategies. Professor Gong, the floor is yours.
Thank you so much. May I have my slides? Today I'm going to discuss with you 2 questions. First, here is a Internet Governance Forum. We talk about Internet, we talk about digital technology, we talk about the artificial intelligence. So the first question is, what is the overarching goal of the digitalization? What is the overarching goal? What is the digitalization we want? So the second question is how to achieve these goals. So first, now today the world is in the course of 2 transitions, or 2 transformations. First is the digitalization. Let's say because the digital technology is a technology, generative, revolutionary, general purpose technology, they change our world, change our economic life in a profound way. But what is the purpose for this? this transition should not be a technology-centered transition, be a people-centered transition. However, the biggest problem facing to the humanity on the earth is how to sustain the human life on the earth. So here is the 17 sustainable global sustainable goals that are common goals for the humanity. These are common tasks for all countries. So to the core issue of these goals is to balance the increasing of the human well-being and decreasing the natural cost. So these goals are about human well-beings, and these goals are about the natural cost. And these goals are linking the human well-being and the natural cost. So that's a core issue of the sustainable development. This picture from IPCC shows you since the Industrial Revolution in the 19th century, the average Earth surface temperature is increasing. It's increasing. However, if we move out all human activities, industrialization, and so on and so forth, we have to see this change of the temperature of the Earth's surface. That means that will keep in the average level as it's at it was millions of years. So the key issue is to save conditions of the Earth for the humanity, and that is the goal of the digital transition. That is the goal of digital transition. That's a human-centered digitalization. So this is not my personal opinion. That's a consensus of United Nations, the member states, 196 member states. Here I see the newly adopted Global Digital Compact by the United Nations 2 months ago. And the first sentence of this global compact is digital technology are dramatically transforming our world. They offer immense potential benefits for the well-being and advancement of people and societies and for our planet. They hold out the promise of accelerated achievement of the sustainable goals. Sustainable development goals is the goals of the digitalization. And there are some objectives. The first objective, hmm? No. Oh, so anyway, the first objective of the Global Digital Compact is to achieve, uh, uh, to accelerate the achievement of the sustainable. Next page, please help me. Next page. Can you go to next page? Oh, okay. So, however, we have the goal of the digitalization. The question is how to achieve this goal. In the narrative, as mentioned by Dr. Long, it's a coordinated transformation of digital and green transformation. But to coordinate transformation, we need coordinated capacity. We have to turn these technical key technologies, 17, I named 17 of them, and the 17 sustainable development goals, and to turn this into so-called digital coordinated digital capacity and sustainability capacity. Only with this, we can achieve our goals. Capacity building, uh, as mentioned by Provost Peng, education, the key to achieve our goals. So finally, because of limitation of time, I just conclude my presentation in 3 words. Understanding the digital and green transformation, and setting sustainable development as a goal of digitalization, building capacity for the digital transformation. Thank you so much. I stop here.
Thank you, Professor Gong, for your brilliant presentation. Next, I'm delighted to invite Mr. Torbjörn Fredriksson, Director of the Office of ICT Policy at the United Nations Conference on Trade and Development, UNCTAD. He is also the head of UNCTAD's work on e-commerce and digital economy. Welcome, Mr. Fredriksson. Please remember to share your slides.
Thank you very much, Madam Moderator, and let me start by expressing my appreciation to the China Cyberspace Affairs Administration and to Tsinghua University for allowing UNCTAD to contribute to this very important dialogue on the shift to low carbon and a more digital economy and society. I'd like to share with you some findings from our recent report, the Digital Economy Report 2024, and I will seek to be very brief, but I hope that participants can also get access to the presentation afterwards. Let me see if I can get to the next slide. Yes, thank you. So the digital technologies are rapidly transforming our economy, as you know, as has been said already. This is creating a much faster and much more powerful interaction between people and machines in the digital space. But at the same time, we know that we have big digital divides. Many countries are far behind in taking advantage of these digital opportunities. In addition, we have the parallel development of planetary boundaries being breached, including from climate change, but more in many other areas as well. So from that perspective, it is very important to ensure that the development of the ICT sector of the digital technologies is also environmentally sustainable. In fact, we can see already that the ICT sector is generating greenhouse gas emissions of a similar magnitude as the aviation or international shipping industry. China is, of course, very important in this context because China is a giant in the context of the digital economy. And we have just a few examples here on this slide showing the tremendous progress that China has made in digitalization and is now a very important force for the globe in terms of digitalization. In the report, we take a life cycle approach to exploring the environmental footprint of digitalization. We have been talking so far a lot about how digital technologies can help with environmental concerns, but we also need to recognize that digitalization in itself is generating an environmental footprint. So we're looking in the report at the production stage, at the use stage, and at the end of life stage of the life cycle. And we're looking at the direct effects in terms of natural resource depletion, energy use, water use, greenhouse gas emissions, and pollution, and some others. If we start with the production phase, we often think about digitalization as being something virtual, something happening in the cloud. But the reality is that it has a very heavy material footprint. For example, to produce one laptop weighing around 2 kilos requires the extraction of 800 kilograms of raw material resources. And we also see that the devices that we're using in the digital economy are becoming more complex. For instance, when we produced telephones about 50 years ago, we needed 10 of the elements included in the periodic table. By 1990, we used 27 such elements. And now when we produce smartphones of various kinds, we use 63 of the elements in the periodic table. That is more than half of all the known elements on Earth. The same minerals that we use when we produce the digital technology are also the same that we use to provide a more low carbon environment. So that means that these two transitions that we are witnessing towards a low carbon economy and towards a more digital economy is generating tremendous demands for metals and minerals. For example, the demand for cobalt, graphite, and lithium is expected to increase by 500% until 2050. At the use phase, I'm just zeroing in here on the data centers because as we shift increasingly to computing intensive technologies like artificial intelligence, the virtual reality, and crypto mining, and so on and so forth, this is generating a tremendous increase in the need for electricity and water that are used by data centers. And the big data center operators, they can no longer keep their greenhouse gas emissions stable or reduce them because of the growing demand for energy and electricity. This is having a strong impact both at the local level where the data centers are located, and of course, if it generates more greenhouse gas emissions, it will also have global implications. The third phase is about how we deal with the waste from digitalization. And here we have seen a growing amount of waste being generated over the past decade or so, in an increase by more than 30%. And we can see that most of the waste per capita is generated in the most advanced economies, the most digitally ready economies. Unfortunately, a lot of the waste that is generated is not collected properly, not collected formally, and therefore also not managed formally. At the global level, only 1/4 of all the digitalization-related waste is currently collected formally. In China, that share is around 16%, and in Africa, it's only 1%. So we have a long way to go to improve that situation. And one of the problems is that many developing countries lack proper legislation to organize the formal collection of waste, and especially here, digitalization-related waste. An overall recommendation of the report is that we need globally to move more towards a circular digital economy. The production of digital products currently is very linear, and that increases the need for raw materials, and it reduces our ability to extract valuable materials from the digital devices and servers and so on that they come to the end of life. So this is an area where there's a huge potential for improvement, and this is something that requires a collective effort across stakeholders and across countries. We are also in need to address what we call the double bind of developing countries. You can see that currently most developing countries have to bear a high share of the cost of digitalization from an environmental perspective, but many are not very successful in benefiting from these digital opportunities. So we need to both help countries to deal with the costs of digitalization in terms of the environment, but we also need to continue to support countries that are far behind in order for them to be able to use digital technologies to address the environmental concerns. Finally, let me say that in order for us to make progress here, we need to work collectively. As the previous speaker was saying, we have come to an agreement at the global level to work together to build the Global Digital Compact. We need to better integrate what we do in the digital space and what we do in the environmental space. And we need to strengthen the capabilities of the poorer countries to be able to develop the right policy responses in this area and also to benefit more from digitalization. I will end that, and I will just direct you to the report for those who are interested in learning more about this. And I thank you again for allowing me to participate in this session. Thank you very much.
Dear ladies and gentlemen, dear Professor Gong Ke, Mr. Wang Jianchao, Ms. Long Kai, dear Professor Peng Gang, and Ms. Zhou Taonan, dear friends. First of all, it's my great honor to express my warmly welcome to you, to all of you. Thank you for coming. Nowadays, information technology, especially AI, is being widely deployed, bring significant improvement in productivity and allowing people to enjoy tremendous benefit. A brand new age, intelligent society is coming. But as the English novelist Charles Dickens said, it was the best of times. It was the worst of times. AI also brings unpredictable risks and challenges. To focus on these risks and challenges, Tsinghua University established a platform research institute, ISG, Institute of Intelligent Society Governance, in 2019. The ISG focuses on interdisciplinary research on AI social impact, and its mission is to create a humanity intelligent society. Since 2021, to investigate the social impact of AI, Chinese government launched a nationwide initiative called AICE, which stands for Artificial Intelligence Social Impact Implement. There are 92 experiment base was established, and more than 2,000 scenarios were set, with about 30,000 people involved. To my knowledge, this initiative is the largest scale social experiment on AI application worldwide. According to our research, intelligent society has five key characteristics, including information rich, instant feedback, reshaping of cognitions, deconstruction of recognition, voice of the long tails. We also, we also studied some concepts such as information cocoon, group polarization, opinion meaning pollution, platform power, energy consumption, online gaming, and a digital label. All these concepts have been studied in my new book, which was released yesterday morning. We have found that it is a significant challenge to enable low carbon development through digital technology. While consuming energy, AI also have huge potential to reduce energy consumption, promoting low carbon development across society, especially in traditional high energy consumption sectors such as power system, transportation system, heavier industry, and construction business. For example, in Edos, a western city in China, which is famous for its energy industry, we have examined how AI facilitates the transportation of energy industry. Our research showed that the coordinated transformation of digital and green development can reduce energy consumption and promote low carbon development. Ladies and gentlemen, the history of human society is the history of science and technology development. Intelligent society is an amazing age. AI is one of our greatest inventions in our history. But in the future, people must not and shall not become slaves of technology. Albert Einstein, the greatest scientist, once remarked, concern for man himself and his fate must always form the chief interest of all technical endeavors. Overcoming these challenges is a tough work. As highlighted in a UN report recently, governing AI for humanity, it is not technological change itself, but how humanity responds to it that ultimately matters. Today, we gather together to show our hope and ambition for the future. Let's work together to make sure that all nations, all people all over the world can benefit from the coordinated transformation of digital and green development, and to build a human-centered, humanitarian intelligent society. We shall do it, and we must do it. Thank you.
Thank you, Professor Su, for your insightful presentation. Now let me welcome Ms. Dou Guimei, Principal of Tsinghua University Primary School, and also co-director of the National Experiment Base of the Intelligent Society Governance. Ms. Dou, the floor is yours.
尊敬的龙凯局长、彭刚副校长，来自全球各地的朋友们，我是来自清华大学附属小学的校长窦老师。
Distinguished guests and friends from around the world, I'm the principal from Tsinghua University Primary School.
我想从现在屏幕上出现的52年前发布在联合国的一篇课文，收录在我们中国的小学语文教材里，叫做《只有一个地球》讲起。
I would like to start from a passage from the UN 52 years ago entitled We Only Have One Earth.
这是我和学生们在课堂上借助这个教材的内容，然后我们一起确立了一个特定的学习主题，把教材的理解，然后转化为到社区里发布环保倡议。
This is a typical case for topic-based learning practice in my class. Advocate for a low-carbon lifestyle in the community. Finally, we expanded to the proposal for the whole school.
我们越来越觉得，随着社会的发展，我们的学科的学习必须和我们的实践相结合。于是，我们走到了社区，发出了倡议。我们还在开学典礼的时候，我和所有的几千名师生发出了用 AI 赋能还丁绿色低碳校园的倡议。
We think that topic-based learning practice is about coming out of the classroom and apply what you learn to daily practice. I've been working on topic-based learning for the past 30 years. After years of exploration, this practice has won the most important prize in China's fundamental education.
所以呀，主题教学呀，就是从学科的研究出发，在今天这个时代走出教室，加强实践的运用。我们越来越觉得，中华民族对我们汉母语啊，特别强调文化自信，讲文以载道，以文化人。那么这样一来啊，就在我们这些年的研究过程当中，我和团队们一直研究主题教学，就是我们类似于今天的叫大观念教学，来培养学生的核心素养。所以从这些年的实践研究当中啊，也获得了首届国家教育教学的成果的最高荣誉奖。那么这10年间啊，我又带领的团队形成了主题教学的理论与实践的成果，并在今年的11月1日正式发布，也成为国家成果的持有的深化者。
I've been working on topic-based learning for the past 30 years. After years of exploration, this practice has won the most important prize in China's fundamental education. Then we still pay a lot of attention to theorizing the framework for topic-based teaching and collect a set of work pieces. All this work were finally published in November the 1st and recognized by the nation.
进入智能时代，我们正在尝试运用主题教学的方法论，对儿童的数字素养和生态文明的意识，这些核心素养融入到清华附小儿童站立学校正中央的教育哲学中，并且呀，也结合中国的古老的日晷的文化，与时俱进的含义，然后通过价值共创、路径统筹、激励相融、数质赋能4个机制，来进行全方位的校园的治理改进与进一步的优化。
Now I'm trying to methodology of topic-based teaching practice to digital literacy and environmental awareness education and integrate them into our philosophy of let students be the core of the school. By incorporating traditional culture elements into our classroom, we try to promote environmental education from our 4 main channels, namely value co-creation, path integration, compatible incentives, and digital empowerment.
下面呢，我就以主题教学 AI 赋能绿色低碳的校园来看这4大场景啊。先来看场景1，就是低碳数字平台，这就是在清华附小里装备着的零碳亭，它能实时的监测校园的温度、湿度、风向、PM2.5、PM10、风力发电、电量、光伏发电的电量等低碳的数据。这些动态的数据分析啊，能够通过 AI 环保的状况，那么为我们的学生们认识自然的生态非常重要，也是他们的重要的学习资源。
Taking AI-empowered low-carbon campus as a case for topic-based learning, we have established 4 main scenarios. So the scenario 1, low-carbon intelligent platform. This is our zero-carbon booth that monitors temperature, humidity, wind direction, PM2.5 and PM10 levels, wind power, and PV output. This allows us to dynamically assess the school's environmental status and become the learning material for children.
场景2就是低碳教育的应用。在校园内，我们正在设置了光伏的太阳花。那么学生们啊，可以用数字化的技术助力学生生态的考察，提升对生物多样的这种素养的培养。那么学生就可以在自然资源的宝库中，借助红外相机观察野生动物，这也是他们重要的学习的内容。
The scenario 2 is low carbon education application. In our campus, we have installed a lot of solar flowers. We also leverage intelligent technologies for students' ecological explorations. During the exploration, they use in-framed cameras, telephoto lenses, and AI image recognition to classify wildlife and gain first-hand experiences.
场景3就是低碳交互的空间。碳循环科普的体验，在学校里，我们用沙盘模拟了海洋、河流、城市、森林、油田、工厂、农场、火山以及天空等场景。那么对应场景中的元素就会这样的动起来，来提高学生对环境的相处的平衡的关系的基本素养的培养。
Scenario 3 is low carbon interactive spaces. We also implement several carbon cycle experiences, focusing on simulation in ecosystems like oceans, cities, and forests, bringing environmental science to life.
场景4就是智慧操场的体育运动。在学校里，运动场和走廊，我们都增加了 AI 跳绳、AI 50米、阳光跑、趣味一体机、五感。孩子们在这个过程当中积累了数据，并研发了承制阳光跑的成长树，以一棵树的方式，不断的在班级的集体的赋能当中长成森林，结出果实，然后我们让学生的成长看得见。
Scenario 4 is intelligent physical education. We further add some intelligent applications to traditional PE education, like AI assisted running, among a lot of sport activities. We also develop an intelligent system for students to keep track of their progress in physical education.
所以在 AI 时代，如何处理好小学生的生命的饱满的成长和我们这个时代的相处和和谐？所以我们在开学典礼的时候，这份倡议书呢，我今天也带来了。我想代表全体的这个师生的学生，能够在这个这种基本的素养，也应该成为我们世界公民的应有的一本基本的共识。
Finally, on behalf of all students at Tsinghua University Primary School, I would like to share the Low Carbon Campus Initiative for a Sustainable Future with Global Friends.
所以最后，说一句话：儿童在哪里 ，AI 赋能的低碳校园的教育就发生在哪里。让我们一起共同努力。谢谢。
In short, we believe that where children are, where AI-empowered low-carbon campus is. Let's work together. Thank you.
Thank you for such a wonderful speech on the role of education in AI and no carbon development. Thank you again, Ms. Do. Next, I would like to invite Professor Edward Arawa, former Vice Dean and Director at the Lee Kuan Yew School of Public Policy, National University of Singapore, to deliver the speech. Welcome, Professor Arara. Please share your slides. Yeah.
Can you hear me?
Yes. Wonderful.
Thank you, Professor Fang, and to colleagues at Tsinghua University for this invitation. I am honored to speak to you today on the topic of modeling clean energy transition using AI, which is the current project of my interest. Um, AI can help improve climate models, as the recent Economist magazine has reported. Artificial intelligence is helping improve climate models, improve prediction accuracy, improve policy making, reduce computational costs, and to scale at regional and global patterns. But my focus is not on climate prediction, but on how can we use AI to help us create better models for energy transition. So I created a model on clean energy transition. In this model, you have the dependent variable clean energy adoption as a function of policies, infrastructure, fossil fuel risks, and other variables. I'm still working on this paper, but basically the idea is how to use AI to do a complex modeling of this clean energy transition. The idea here is that this energy transition depends on so many factors, and governments and donors and UN agencies should be able to pay attention to these variables. So one important factor to monitor is the policy support for clean energy transition, the readiness of national infrastructure in terms of the grids, storage, and offshore facilities, uh, the fossil fuel risks such as the volatility, supply security, geopolitical risks, and the risk of declining investments in fossil fuel. Then, of course, you have the issue of availability of financing for clean energy, especially for developing countries. Then you have the issue of the grid, uh, electrical grid. Are they ready to be integrated, especially for renewable energy like solar, wind? Then you need to look at market maturity. What is the level of competition and openness in the energy market? Then you have to factor in social acceptance. Do the people accept clean energy? Then you have to look at carbon pricing regulations, carbon taxes and emissions limits, nationally determined contributions. You have to include that in the model as well. Then you have to also look at, include in the model, the rate of technological innovation, such as advancements in solar panel, wind technology, the efficiency and storage of batteries, as well as developments in nuclear modular reactors. Then you also have to look at energy demand, which is a function of economic growth, and then the demand for clean energy over time. And so, what I'm trying to say is that those of you who are interested in the audience to collaborate with me on this project, how can we use AI to do a complex modeling of this clean energy transition? You can get in touch with me. That's all I wanted to say. Again, thank you to Professor Fang for this kind invitation. Thank you.
Excellent. Thank you, Professor Eduardo Araro. Now, next, I would like to invite Professor Salva from the School of Business at Queensland University of Technology. Welcome.
wait for my slides. Okay. Is this on? Yeah, you can hear me? Okay. All right. So I will be extremely brief because we are almost out of time. But so one of the things that I would like to highlight is we need energy to generate capital. That's why we need energy. And as our needs to create more capital, we are going to either use more energy or less energy. And to solve this issue about low use of energy, we really have to focus on where does energy get used in terms of transitioning from capitals and the role of information tech. Very quickly, if you just go to the next slide, if you go to the next slide. Oh, okay, okay, so this is a project that we have been working on where we are modeling how do you transition from these various issues of capital. So there's economic capital, there's human capital, there is natural capital, that's the environment where you draw on resources or you can regenerate. There is also organizational capital, that is your government, your businesses. There is social capital, that is what keeps a society cohesive and organized. And at the end, you have symbolic capital, that is the brand of your country, brand of your urban area, brand of your city. So you can view this as an input-output matrix. Basically, you are exchanging one form of capital for another, and you are really trying to solve for efficiency. So your capital inflow and your capital outflow. And hopefully, the more outflow you have and the less inflow, the more efficient you will be. I will not go into this, but we have modeled all of this and the role of cognitive computing technologies to help you get more efficient and use lower energy. So give you just a couple of examples. We have used digital twins to be able to analyze what are the inefficiencies in moving capital from one place to another. Okay, in terms of moving capital, because if you can model how capital moves, then you can increase the efficiency and use lower energy. Another way is you can actually understand what is inhibiting the movement of capital. So here you have two different images where you just strategically relocating and using information technologies, you can increase capital intensity. Here is an example of how AI is being used to regenerate capital so that you are recycling, and it goes back to the comments made earlier about circular economy. And just one more, here is where you can map using cognitive computing technologies where your capital needs to be upgraded or maintained before it loses complete value. So how do you do that? I'm happy to share more examples of these projects we are doing across the globe. And with that, thank you very much.
Thank you, Professor De Souza. Now, let's welcome our last speaker, Ms. Zhou Chaonan, the chairperson of Range IDC. The last but not the least, the floor is yours.
尊敬的王建朝局长、龙凯局长、彭刚副校长、龚科校长，来自全球各地的嘉宾们，大家上午好！非常荣幸的参加这一次数字技术助力绿色低碳发展开放论坛。我来自中国润泽集团，是一家专门从事人工智能产业提供规模化、绿色化、智能化算力资源的高科技企业。在这里，我想简单的向各位分享几点润泽关于智能技术助力绿色低碳发展的实践和思考。
Distinguished guests and dear friends from around the world, good morning. It's a great honor to participate in this open forum on digital technology empowering green and low carbon development. I'm from Range Group, a high tech enterprise dedicated to providing large scale, green, and intelligent computing power resources for the AI industry. Today, I would like to briefly share some of our practices and thoughts on how digital technology contributes to green and low carbon development.
习近平主席强调，要健全绿色低碳发展机制，支持企业用数字技术、绿色技术改造升级传统产业。可以说，数字技术与绿色技术的双向奔赴，已经成为当今社会转型发展的重要议题。
Chinese President Xi Jinping has emphasized the importance of establishing mechanisms for green and low carbon development and supporting enterprises in upgrading traditional industries with digital and green technologies. Indeed, the integration of digital and green technologies has become a vital topic in the transformation of modern society.
润泽集团自从成立以来，秉承产业报国的使命，致力于为中国乃至世界数字化社会转型提供绿色、可持续的算力基础设施支撑。经过15年的发展，我们已经在京津冀、长三角、粤港澳大湾区、成渝的重庆、海南、甘肃等区域布局了7个智能算力产业园，努力为各行各业的智能化转型贡献力量。
Since its inception, Range Group has adhered to the mission of serving the nation through industry and is committed to providing green and sustainable computing infrastructure to support the digital transformation of societies in China and global nations. Over the past 15 years, we have established 7 intelligent computing industry parks in China, including Hebei Province, Pinghu in Yangtze River Delta, Foshan and Huizhou in Guangdong, Chongqing, Hainan Free Trade Port, and Lanzhou in Gansu, contributing to the intelligent transformation of a set of industries.
在这一过程中，绿色数据中心和智算中心建设是我们探索的重点。我们都知道，算力的发展离不开能源。我一直认为，算力的终极能源是氢能和成熟的核能应用。但是在最终没有实现之前，我们还需要进一步关注现有架构下的节能技术。
During the process, green data centers and intelligent computing centers have been one of our priorities. As we all know, computing power ultimately depends on energy. From my point of view, the ultimate energy sources of computing will be hydrogen and the mature application of nuclear power. However, before reaching that stage, we must focus on energy saving solutions within the current frameworks.
我国的数据中心绿色节能国家标准的电源使用效率一直在不断的改善 ，PUE 值从1.6逐步降到1.3。我们长期在一线从事这一工作，一直努力攻关克难，探索 PUE 值还能否进一步降低。经过不断的努力，我们自研的数据中心智能低碳全域智能系统，通过模块化的布局、集成化的设备、智能化运维等系统解决方案，实现了能源利用效率的持续优化，将 PUE 值降到了1.15左右。如果使用最先进的静默式液冷制冷 ，PUE 值可以进一步降低到1.09。
The power usage effectiveness (PUE) of data centers in line with national green energy standards has been continuously improving from 1.6 to 1.3 in the past several years. As the explorers in the frontier of the industry, we have been keeping on exploring whether there is still any gap to further reduce the PUE. Through years of effort, we developed a self-designed, intelligent low-carbon cooling system for data centers, which optimize energy efficiency through modular design, integrated equipment, and intelligent operations. This innovation has reduced PUE to approximately 1.15 with the most advanced immersion liquid cooling methods, it can reach as low as 1.09.
这项创新技术具有良好的示范带动作用和社会影响，先后获得了工信部等多部委遴选的国家绿色数据中心等荣誉。未来，绿色节能是智能社会发展的必由之路，必将会产生更深远的社会经济影响。
This project has incurred a significant demonstration impact, earning us recognition as a national green data center from the Ministry of Industry and Information Technology and other government agencies. In the future, we believe that green development will be ultimate trend for intelligent society, and our efforts will yield more profound socio-economic impacts.
与此同时，我们非常关注数字技术助力绿色低碳发展背后的更加深层次的机制问题。为此，我们与清华大学联合成立了智能社会研究院，希望更好地利用清华大学的多学科和润泽集团的技术与实践优势，围绕数字化、绿色化、协同发展以及智能社会转型相关规范标准等问题，联合推出了一批前瞻性、规范化、标准化的系统性的工作，并不断深入研究与迭代。未来希望能够借助联合国互联网论坛等多边国际会议的场合，和各位朋友进一步交流我们的经验成果。
In the meantime, we aim to address deeper institutional challenges behind digital technology's role in green and low carbon development. To this end, we have co-established a joint institute on intelligent society research with Tsinghua University, hoping to better leverage both Tsinghua University multidisciplinary strengths and Range Group's technical and practical expertise. We have initiated several forward-looking projects focusing on the coordination between digital and green development, standards for intelligent society, among other important issues. In this future, we look forward to sharing our insights on important global platforms like IGF and engaging with you all on these crucial issues.
谢谢大家，希望我们一起努力，更好地为数字社会发展助力绿色低碳发展的伟大事业贡献力量。
Thank you.
同时，我想请大家看一个我们的算力大科学装置的推出。
Thank you.
一个视频，2分钟。
Let us work together to contribute to the great cause of empowering green and low carbon development through digital technology. And I would like to share 2 minutes with you with all of you.
Sorry, no voice. Could you help to turn on the voice of this video?
润泽 AIDC One Pro Max 可以在100米范围内实现11万颗超级芯片、13万颗先进芯片、21万颗普通智能芯片、30万颗智能推理芯片等不同类型芯片的网络集群组件。润泽 AIDC
Please switch to channel 1.
在算力时可训练万亿级参数的 GPT-5同等规模人工智能大模型。满载算力时将能够训练超 GPT-5的超大规模人工智能大模型，为人工智能发展提供坚实底座。在提供全球领先的高算力的同时，得益于4成 Chip Link 技术的优势，满载网络建设成本降低约8亿元，创造算力效能提升价值12亿元，从而大幅节约了社会资源，并显著增强了数字经济的价值。润泽 AIDC One Pro Max 支持多模态制冷系统，能够无缝切换风冷、冷板式液冷、静默式液冷等多种制冷模式。该系统特别设计的冷板式液冷技术，可将 PUE 降低至 1.14。这一成就展现了润泽科技在推动中国低碳制算中心发展方面的先锋作用和践行者身份。润泽科技携旗舰产品润泽 AIDC One Pro Max 作为强有力的接力棒，在全球 AI 竞争的接力赛中，助力中国 AI 在接力赛跑中奋勇争先，不断实现自我超越。算力即国力，润泽超级制算大科学装置将为我国在全球 AI 竞争中做出润泽贡献，稳定、安全、可靠、绿色，尽在润泽科技。
Okay, wonderful speech and also the video. And I want to take the last chance to thank you all, our distinguished experts, and also audience for your patience. We really run out of time, but I think we also had a wonderful discussion today. I hope we will keep in touch and keep our passion on this important issue in our area. In the end, I would like to claim that we are closing our events today. So please keep in touch. See you next year. Thank you.